Hello everyone. Today we discuss about the BSc 4 sum paper Thermal Physics and Electronics in the chapter Unit 1 Thermodynamics. Basic concepts of thermodynamics. Firstly, what is a thermodynamics? Thermodynamics, the word is describes the thermo means heat, dynamics means motion. The study of heat in a motion is called as the thermodynamics. Example is the gas contained in a cylinder with a movable piston. Homogeneous and heterogeneous system. Homogeneous system, when a system is completely uniform throughout such a gas or mixture of a gases or a solid or liquid is called as a homogeneous system. And the heterogeneous system, when a system consists of the two or more phases which are separated from one another by definite boundary surfaces, is called as the heterogeneous system. What is a system? A system means it is the definite quantity of matter such as a solid, liquid and gases bounded by some closed surface. What is the surroundings? Surround anything outside the system which can exchange the energy and has a direct bearing on behavior of the system. And we discuss about the thermodynamic variables. The thermodynamic variables are described. The thermodynamic state of a system is determined by the four observable properties such as namely composition, pressure, volume and temperature. These are the variables of the system. We see the thermodynamic variables and types of thermodynamical systems, and they're having a three: open system, closed system and isolated system. Open system, the system can exchange the both matter and energy with the surroundings. And a closed system, the system can exchange only the energy but not exchanging the matter with the surroundings, is called as the closed system. Isolated system, a system which is thermally insulated, has no communication of heat or the work with the surroundings, is called as the isolated system. And we talk about the zeroth law of thermodynamics. If two bodies A and B are each separately thermal equilibrium with a body C, then A and B are also the thermally equilibrium with each other. Internal energy. The energy content of a system is called as its internal energy. In practice, it is not possible to measure the total internal energy of a system in its volume can be measured. If a state of a system is changed from initial state 1 to the final state 2 by supplying the heat Q to the system and W be the work done by the system during the change. The system during the change, then its internal energy is given by U2 minus U1 is equal to Q minus W. Then U2 minus U1, then W is taken in left hand side, then we U2 minus U1 plus W is equal to Q. First law of thermodynamics. When a certain amount of heat is supplied to the system which does external work is passing from state 1 to the state 2, the amount of heat is equal to the sum of increase in its internal energy of a system and external work done by the system, which can be expressed by the amount of heat is equal to internal energy plus work done by the system. Then it is the U2 minus U1 is the internal energy and W be the work done by the system. And we talk about the second law of thermodynamics. According to this first law of thermodynamics, heat and energy are the equivalent to the law simply states that the amount of heat is equivalent to the amount of heat used, but law does not say anything about the direction of energy flow or about the range or limit which it can possible. The first law shows that the perpetual motion first kind is impossible, that is a production of energy without disappearance and equivalent energy of another form is not possible. And then it is the first law is failed to explain the why heat always flow from the body at higher temperature body at lower temperature and does not flow in reverse direction. It cannot explain the why vast amount of available heat energy cannot be converted into the mechanical work. In practice, however, there is no engine which can convert the heat from single source into the useful work without rejecting the some heat to the sink at lower temperature. That is a perpetual motion of a second kind, that is a production of internal energy of one body is impossible. These several questions led the formulation of the second law of thermodynamics. Thus, the second law of thermodynamics is the generalization of some observations and expressions and particularly concerned about the with the direction in which energy transfer takes place. There are some scientists are stated by the second law of thermodynamics. Firstly, Lord Kelvin's statements. In case of heat engine, it has been observed that we cannot obtain to a continuous supply of work from single source. A single supply of it. That is, the presence of colder body is must for the continuous conversion heat into the work. On such consideration, Lord Kelvin stated that it is impossible to get continuous supply work from body by cooling it to a temperature is less than the surroundings. And another scientist are stated by the Planck statement. According to Planck, it is impossible to construct engine which in working completely cycle will produce no effect other than the absorption of heat, reverse wire and conversion into the equivalent of the work. And that is a perpetual motion second kind is impossible to the engine must reject part of the heat absorbed to a sink to the lower temperature. These two statements can be combined into the one system is known as the Kelvin-Planck statement. Second law of thermodynamics. It is impossible to construct an engine which operating this cycle has a sole effect of extracting the heat from reservoir and performing the equivalent amount of work. And these are the combined statement. Planck and the Kelvin, these two scientists are combined statement is. And another scientist was the Clausius statement. According to the Clausius, heat cannot flow from itself from colder body to the hotter body. The above statement is based on the performance of refrigerator. That is a heat engine working in the backward direction. It is clear that from above statement, the natural flow of heat is always from hot body to the cold body. If a heat is transferred from cold body to hot body, work had to be done by the external agency. Thank you.